Hello everyone, good evening. This is Bharti Raja. I am just going to quickly talk about, not taking much of time here, maximum of 15 minutes. So going to talk about Zephyr RTOS on reconfigurable platforms. Again, I think this is kind of a emerging technique where reconfigurable computing is used for quite a long time in different areas. But when talk about the embedded ecosystem, reconfigurable computing with Zephyr RTOS is becoming kind of they're covering most of the areas like research, or in terms of academia as well as industry, covering a lot of areas. So I just want to touch base on what are the key things that have been uh, taking part in terms of reconfigurable computing, as well as uh, what are the challenges that is been associated with this, and what we can expect in the future. So I just going to have this as my agenda. So before getting into the talk, myself, Bharati Raja, I'm working for a company called Linumiz, and I predominantly we work on Zephyr RTOS and as well as embedded Linux, and we are, more of information can be found in linumiz.com. And we are based in two locations. One is Germany and as well as India. So at the end, I'll just give you more glimpse of what we are doing and what kind of activities that we are performing. So quickly jump into the talk itself. Why reconfigurable platform? So what is the major difference between an FPGA or kind of when we talk about reconfigurable computing, we just mainly talk about the FPGA, and we on the other side we have as an ASIC application specific integrated circuit, and which is MCU for that matter for when you talk about Zephyr RTOS. So what is the advantage what we have with FPGA with ASIC is that the reconfigurable computing provides you a flexibility in terms of software, hardware, co-design. Also, you can have a custom ISA when you want to look for and specifically design an ISA, the new ISA for an any chip which you want to tap out. So also you have when you have a specific software in mind, you want to collab with hardware, you can just go with hardware software co-design. So that is where FPGA plays a major role in terms of prototyping, as well as there are special use cases that been FPGA is used in terms of reconfigurable computing when compared to ASICs. I'll just take a moment to explain it in upcoming slides. So when you talk about reconfigurable platform, we have these are kind of examples that been available today, specifically with RISC-V architecture. Okay, when we talk about RISC-V, we have a lot of other. I'm just listing out a few of the examples here. We have a lot of other examples also out there in the market. So specifically with Neo RV32, which is kind of more of academic oriented, and you have RISC-V, Pico RISC-II, and market, all these kind of our softcore processor, RISC softcore processor. Also, currently we have MicroBlaze, Nios II, and OpenRISC. So you have an ISA exploration and custom peripheral sets, specifically when you talk about reconfigurable or open source, open core for an reconfigurable platforms. So when we talk about Zephyr, how Zephyr fits into this case? Okay, why Zephyr exactly fits into the case? Yes, most of this audience here will be knowing this. So you know, Zephyr has a very small footprint and modular, which is much more suitable for a reconfigurable computing in terms of resource constrained devices. And you have an both architecture support, which is kind of which follows specific standards, so which is very much good. And also we have an open active community ecosystem, which is driving the entire Zephyr community. Zephyr community is very huge, so where fits the need of using it for an reconfigurable computing. And when you talk about real time and it is much more of scalable. These are the key points why Zephyr fits into reconfigurable computing platform. Okay, so when you talk about the current landscape as an architecture, as I mentioned earlier, we have these are the major architectures that means already supported in Zephyr, and also there are more of where you can see more of things are already upstream available in Zephyr project already, and where MicroBlaze from Xilinx already supports Zephyr, and also you have Nios II OpenRISC are already supporting Zephyr. Also, there is a very various level of maturity that has been achieved in terms of support for reconfigurable computing. And when you talk about upstream, and there are as well as downstream branches or experimental branches available for reconfigurable computing in terms of Zephyr is concerned. So as you see, this area is growing. We are expecting more to be getting upstream in near future. So what is the main thing when you talk about Zephyr on reconfigurable computing? We have SOC abstraction via device tree. As you know, the SOC abstraction is done in a device tree model in Zephyr. And also the LightX SOC, the open softcore processor, is widely used in Zephyr. Also, we have different board supports that has been already available. As you see, Hartley from Xilinx board, and also the D09 is already supported. These are the different. Not only this, we have plenty other boards from an open source, reconfigurable computing point of view. We have a lot of other boards being supported, but however, these are. I just take it for an example. The challenge here is standardizing the FPGA based boards, because each and every board has its own reconfigurable platform, and the standardizing these boards is a little bit challenging when compared to the MCU. Also, in terms of device tree and subsystems, you have the core drivers already supported. Yes, you have the UART, GPU, ICC, SPA are very much stable in terms of comparing to the other things. These all are kind of peripherals that have been already fully supported for reconfigurable computing. And when you come, also where there are timers and interrupts, needs to be careful tuning, because it depends upon the boards and FPGA clocking as well. Because FPGA, as you know, it has its own clocking, so there needs a much of tuning up the timers and interrupts needs additional effort. Also, we see a lot of emerging support for network, specifically when coming to the reconfigurable systems, and subsystems like shell logging file systems already being supported. So here, what do we want to? What I'm trying to conclude here is there are more of peripherals that have been off the shelf supported, but there are also ample amount of additional effort that's been involved. So that's how comes to the key challenges, where we have clocking and timing accuracy. When you talk about, there is kind of a key challenge in terms of when you specifically compare to the MCU boards, development boards to an reconfigurable computing boards. And also, in terms of memory mapping, there are supports available. Still, there are kind of a lot of efforts that needs to be done. In terms of interrupt handling, diversity, and also in terms of debugging, whenever when you just put in Zephyr onto any reconfigurable computing board, the debugging has to be taken care on additional thing, because it is not kind of, I mean, just get into a small example there where it off the shelf, we have to do your own debugging across, like from the hardware level all the way to the software level. So this is kind of a little bit challenging areas which needs to be addressed, and I believe this community is working towards this. Also, I mean, as I said, these are some of the major opportunities that have been available in terms of reconfigurable computing when you're putting the Zephyr on board. Say the software, hardware co-design, as I said in the earlier slide, when you talk about designing and custom instruction set in place where you can use this as a platform in along with the reconfigurable computing, you can just design your own ISA, and also you can just have your own software in terms of Zephyr porting to it. And I have an example case study, I will show the same. And custom accelerators, which is gaining more popularity now in terms of cryptographic accelerators, AEML based accelerators, that is been an opportunity that is being taken into account now. These days, I see a lot of things are coming up. In terms of safety critical, I just want to highlight here. Yes, Zephyr is taking different directions, and recently Linumiz has an partnership. I mean, I want to highlight here because Linumiz is taking a close partnership with Infineon in terms of for an automotive. So where we are just working towards the safety critical adaptation as well. So that's how Zephyr is growing as an ecosystem, and also you can be adopting the reconfigurable platform for such adaptation as well. So we have, as I said, you have an ISA prototyping and research, which is predominantly we can use this Reconfigurable platform as one of the major area. And here is one case study which I want to highlight, where this is the Neo RV32, which is purely RISC-V based, RISC-V based open source architecture, which I just tried in terms of research and development. I'm closely working with the accelerator, the cryptographic accelerator for this processor. And this is an MCU, which is purely HGL is open source, where you can put, you can just use any of the IDEs, you can compile it and get a bin file out of it and flash it to an FPGA. Yeah, much of the FPGA boards are supported, Xilinx series, Lattice series, and also a lot of other boards are supported in terms of even Ultra boards are supported, where you can just generate the bin file out of it, and once you flash it, you have the onboard with the bootloader, where bootloader comes up with the first stage, where you can compile the Zephyr. Yes, Zephyr is off the shelf supported for this softcore, and you can just compile using this code as you using the best build, and you can yes, this is kind of a primary thing where you need to rename the binary which is being generated to rename it, and you can sideload the binary. This is an example which I just want to show here, where you can sideload the binary of the Zephyr, whichever you compile, and you have the bootloader already been having the all the information displayed once you connect to the console, serial console. Then once you boot up these, like you can sideload the binary using the serial port, and once you boot it, you can just see the hello world from Neo RV32 as a softcore. This is a simple example which I want to show it to you, where this is kind of a starting point. Whosoever were interested to us using a softcore processor for developing Zephyr or porting Zephyr to any different softcores, this is one of the starting points where you can try on your own. So future outlook, whatever things is like, we can see where there is support for SMP on FPGA cores, which is we are looking forward, where community support is also coming up, and also where expansion of ISA in terms of RISC-V. When you talk about you have a custom ISA which you can develop, and you can just have a for the custom ISA you can add support for the Zephyr, and you can just use the same way which I explained earlier. So these all kind of, again, when you talk about the safety and prototyping, the reconfigurable computing is one of the major best choice for it. So this is all about the talk about the reconfigurable computing and Zephyr support for the reconfigurable computing. And I just quickly conclude here with what we as a Linumiz do. Now we do embedded Linux, Zephyr RTOS consulting, and we predominantly work on Zephyr RTOS as well as Linux, and do the consulting for different activities in terms of board support package, firmware development, and other activities as well. These are some of the public presences and the public talks presented by our different colleagues from Linumiz. And these are the different things. Okay, that's all. I just conclude here. I stop here if you have any questions. Sorry, I think I just took, I was in time, I believe. Yes. I know, I just was expecting a 30-minute talk, but I got only 15 minutes, so I couldn't explain much.
I got a question.
Yeah, please.
How do you do debugging on the FPGA? I guess you have to, you need some like
okay,
or something like on the FPGA, or
yeah, actually FPGA has specifically when you talk about Neo RV32, it's OpenRISC support is already been enabled for it, so you can use it for debugging and other aspects.
But then it
hardware support is also
the hardware component. You have to
figure
that it's on the FPGA, and then you can connect.
Yes, right. So any more questions? So I and my colleague here, Madan, will be available. If you have any questions on this talk or anything you want to discuss, we will be available here. You can connect with us anytime. So any more questions? I'll close it up.
You have a live demo?
Sorry, I didn't bring the live demo. I just have it. Maybe if you can, if you need, I can just share it with you. Maybe I'll just get your contact. I can just share my live demo there. I mean, apart from this is purely FPGA fabric. Also, we work with, we have kind of ARM plus FPGA, right? PS system and PL system, where we just program from PS to PL, where we have the softcore running on the PL, and we just use the PS system to Zinc kind of processor. I mean, again, we can use we can utilize that kind of architecture also for porting Zephyr. Okay, thank you.